Okay, and finally, moving on to example C, y equals 2x cubed plus 1 over x squared minus 4. First thing we want to consider would be our asymptotes. Well, as we think about our horizontal asymptote, remember we consider our our degrees. Our degree on top is 3, and our degree on bottom is only 2. When the degree on top is greater than the degree on bottom, you have no horizontal asymptote. Again, cool, but not necessarily easy in helping us graph. So we're going to have to plot a lot of points because we don't know where our graph is leveling off, if it's going to level off, or what's happening. So we move on to talk about our vertical asymptote. Now we find our vertical asymptote, remember, by setting our denominator equal to 0. Notice first that we can factor this guy. So our denominator factors into x plus 2 and x minus 2. Well, just like when we solve quadratic equations and we set them both separately equal to 0, we say, oh, x plus 2 equals 0, x equals negative 2 then. X minus 2 equals 0, x equals positive 2. So I've got my vertical asymptotes that I'll throw in my graph. And then I consider my intercepts next. So my x-intercept I find by setting my numerator equal to 0. Oops. There we go. So I set my numerator equal to 0, 2x cubed plus 1. I subtract 1 from both sides. 2x cubed equals negative 1. Divide by 2. X cubed is negative 1/2. Well, to get rid of x cubed, I cube root both sides. Am I allowed to take the cubed root of a negative number? Hopefully we know the answer is yes. So x is going to be the cubed root of negative 1/2, which is pretty much about negative 0.794. Okay, so that's going to be like there-ish. And then I'm going to have my y-intercept. Well, to find our y-intercept, we just plug in 0 for x. So then I have 0 plus 1 over 0 minus 4. I have negative 1/4. Now, having already done this problem, I'm going to let you know right now, we are going to want to scale our y-axes by something other than 1. Let's go ahead and count by 2's. So plotting that point at negative 1/4, that's going to be just below our origin. Now we just need to start plugging in values for x. More numbers are better. So it's going to seem like we're plugging in a lot of values, but that's okay because, like I said, the more the better. So we've got our vertical asymptote at x equals negative 2. We want to plug in a couple values to the left of that. So let's say negative 5 and negative 3. And I always try to plug in points that are really, really close to your vertical asymptotes. So let's even go negative 2.5. Now, plugging in negative 5 into our function, we end up getting negative 249 over 21, plugging it in for x, which for our intents and purposes is basically negative 11.9. That's how I knew we wanted to count our y-axis by something other than 1s. And we'll plot all our points when we're done plugging them in. So then we plug in negative 3, and we actually end up getting negative 53 over 5, which is negative 10.6. Plugging in negative 2.5, we get negative 121 over 9, which is negative 13.4 repeating. Cool. So now that we've got these points, we'll plot all of those. So left 5 and then down 11.9. Remember, we're counting by 2's. 2, 4, 6, 8, 10, 12, just below that, or just above it, excuse me. Then negative 3, negative 10.6. Let's see, there's negative 10. So we're like there-ish. And then negative 2.5 got us negative 13.4. So counting by 2's, 4, 6, 8, 10, 12, 13. So those are kind of a weird array of points. But we know that our graph goes down towards that vertical asymptote because that's what plugging in negative 2.5 led us to believe. And then we have no horizontal asymptote. What's actually going to happen is we are going to continue to go back downwards, which seems a little bit strange, but the more numbers we plug in, the more likely that outcome becomes. So when in doubt, plug in more numbers and check your answer in your graphing calculator. Now we're going to plug in numbers between -2 and 2. So in between are two vertical asymptotes. Now, good news, we already know what happens at our x-intercept, which we found to be -0.794, and what's happening at x equals 0. So let's just plug in -1 and +1 then and call it a day. Plugging in -1 for x, we get a +1/3. Thank goodness, normal numbers. And plugging in +1, we get -1, even better. So I've got -1 up 1/3. Remember, we're counting by twos. And +1 at -1, we're counting by twos again. So only halfway to our first tick mark. And then remember that your graph is going to go all the way upward or down. But based on where our points were leading us, we could tell that we were going up to the left as we approached that vertical asymptote and down to the right as we approached our x equals 2 asymptote. Now we still need to plug in some points to the right of that x equals 2 asymptote. Again, doesn't hurt to plug in one super close to it. So if we plug in +2.5, we'll see what's going on. And we'll plug in a couple others for good measure, maybe +3 and +5. Plugging in 2.5, we actually get 43/3, which is 14.3 repeating. Plugging in 3, we get 11. Woohoo! And plugging in 5, we get 251/21, which is 11.95. Pretty much, estimating. So with those points, we'll go ahead and plot them. So we go right 2.5, so just on the other side of that x asymptote or vertical asymptote, and we go up 14.3. Remember, we're counting by twos. So we go up 7 tick marks and go just above that. Whoops, and that was supposed to be at 2.5. So pretty much right there. And then at 3, we're down from there, only up to 11. So that's going to take us right here. And then over at 5, we're up to 11.95, which is almost to our 6th tick mark. So we can kind of see from those 2 points that we're for sure going up and up and up as we go to the vertical asymptote. And then again, we have no horizontal asymptotes. So what we actually end up doing is shooting back upwards. So again, make sure you're plugging in lots and lots of points for these guys, plugging them into your graphing calculator to check your answer, and always checking your work and going slowly.